Hello. I hope you've all had a good holiday break. I've had some questions about weekly homework number 10, problem number 5. So here I'm going to do a quick setup for you. Hopefully this will answer all questions that you've had, get you someplace that you can figure it out. If you continue to have any more questions, feel free to email or post it on the group help section of the winter break folder on Schoology. All right, so the problem says when a 0.2 kilogram mass is suspended from a vertically hanging spring, it stretches from the spring from its original length of 5 centimeters to a total length of 6 centimeters. The string with the same mass attached is then placed on a horizontal frictionless surface. The mass is pulled so that the spring stretches to a total length of 10 centimeters. Then the mass is released and it oscillates back and forth. What is the maximum speed of the mass as it oscillates? All right, well, first off, I am a jerk. This is a doozy of a problem. There's a lot going on here, and a lot of different concepts that we've got to parse apart. All right, first thing I want to point out is what are we looking for? So I'm first jumping to what are we looking for, and we'll go from there. Well, we are looking for the max speed of the block. Okay, so the rate of speed it will have. So what's going to happen is we're going to have this block. We're first going to compress it some, and then it's going to let it push out from the spring, and it's going to bounce back and forth, boing and boing and boing and boing. And at some points it'll be very slow, and at some spots it'll be very fast. I know when it's initially compressed, it has only potential energy, and that's potential energy of the spring. I know that at the quickest, it will not have any potential energy anymore, but it will in fact have kinetic energy. So I know that from the beginning, the total amount of energy is going to equal whatever the potential energy of the spring is, and that's going to equal the kinetic energy when it reaches its equilibrium point, or x equals 0. Centimeters. This would be centimeters. So this hopefully gets you in the idea that we know that the conservation of energy is energy before equals energy after. So then that would only mean that the potential energy of the spring is equal to the kinetic energy of the block, and this is the max kinetic energy. And so we could probably guess that this is going to pop out. Now, I'm not going to do the whole thing for you. I did a lot for you. You should be grateful. You should love me. But everyone loves me. Anyway, what I'm not going to do is I'm not going to tell you how this guy comes into play, and that's kind of a problem because that's the spring constant, which is that determined constant of the spring that matters how stiff it is. So I think that looks good, doesn't it? That's the big thing. Got to find spring constant. Hopefully you can find the max velocity from there. Other things to make sure you don't get tripped on. You want to look for the change, delta x. So if the spring is originally 5 centimeters, if it stretches to 6, so you have to think about what is the displacement. I hope this helps. If you have any further questions, please go ahead and email me or post it on Schoology, and I hope you have a good one. See you on Tuesday.